In this video, you will learn how to simplify fractions. Now, when we say fractions, we're not dealing with our basic, 4 over 8 or 2 over 6. We're dealing now with fractions that involve variables and variable expressions in both the numerator and denominator. So as you are simplifying these type of fractions, here are some steps to take into account. Step 1 is to factor the numerator and denominator, and then from there we can cancel the common factors. And if nothing cancels, we can be looking for opposites so that we can maybe force something to cancel. So example 1, we have 4x plus 8 over 4x plus 4y. So we need to begin by factoring both the numerator and denominator. So for the numerator, I can factor a 4 out, and I'm left with, in parentheses, an x and a plus 2. For the bottom, I can factor a 4 out, and I'm left with an x and a plus y. So I have 4 times x plus 2 over 4 times x plus y. Now notice they both have a 4 in common on the top and the bottom, so I can divide those out, and I'm left with x plus 2 over x plus y. And from here, I cannot cancel any further because of this plus sign on the top and on the bottom. So I cannot divide the x's out. All right, it's only when everything is being multiplied together. Now here with our final answer, just remember that the denominator of any fraction can never equal 0. So there are limitations on what the denominator can be. So this x plus y down here, that cannot equal 0. And if we wanted to, we can solve this for x to see what can x not equal. So if we solve this for x, we subtract y from both sides, and so we would have x not equaling a negative y. So just keep into account that the denominator will have restrictions, and for this lesson we will discuss what the restrictions are for each of these examples. Example 2, we have x squared minus 25 over 3x minus 2 times 5 plus x. Now I want to begin by factoring. Now the denominator is factored already, but the numerator can factor further. We have x squared minus 25, which is a difference of squares. With a difference of squares, I can factor that as x minus 5 times x plus 5. So now, once I have factored, I see that x plus 5 and 5 plus x, those are the same thing. And those can divide out, which leaves me with x minus 5 over 3x minus 2. Now once again, make sure that you remember that the denominator of any fraction can never equal 0. So when I am doing this, I want to look at the original fraction. So look up here, not at my final answer. So looking up here, we see that this denominator cannot equal 0. So what that means is that because everything's multiplied, this part cannot equal 0, or this part cannot equal 0. Because if one of those are 0, when I'm multiplying, 0 times whatever the other part is would be 0, which it cannot be 0. So we know that 3x minus 2 cannot equal 0, and 5 plus x cannot equal 0. So if we solve each of these for x, we would add 2 to both sides for this first, I guess technically inequality, not equation. We would add 2, we would have 3x equals 2, or not equal to, and then divide both sides by 3. So we have x is not equal to 2 over 3. And then on the right side, we subtract 5 from both sides. So x is not equal to negative 5. So it's always important to at least be mindful that there are restrictions on any given denominator. Example 3, we have 2x squared minus 7x plus 6 over 2 minus x times 3 plus x. So I begin by factoring, and the denominator is factored already. The numerator can factor, and we can factor that by getting 2 parentheses. For 2x squared, we would need a 2x and a 1x to get 2x squared. And then for the last term, we need a 6. So to get 6, we can either do 2 times 3 or 6 times 1. If we put the 3 with the 2x and the 2 with the 1x and make them both negative, negative 3 times negative 2 is a positive 6. And then if I do negative 3x and then negative 4x, that would give me negative 7x for that middle term. So I can factor the numerator to be a product of 2x minus 3 and x minus 2. Now notice the x minus 2 in the numerator and the 2 minus x in the denominator. Notice how those are opposites. What I can do is, looking at either the top or the bottom, doesn't really matter. Let's look at the bottom. If you look at the bottom, we can make this 2 minus x into an x minus 2 by pulling a negative out. If I pull a negative out, I'd have x minus 2 in parentheses. If you don't see that, let me just explain a little more clearly over here. 2 minus x, if I pull a negative out, what happens is it changes the sign of what is inside. This becomes a negative 2 and a positive x, right? And that would be true because negative times negative 2 is a positive 2, and a negative x would be negative x. So pulling a negative out changes the signs, and I can change the order so the positive x comes first and the minus 2 comes second. So that would be negative and then x minus 2. And then from here the x minus 2's will cancel, so what I have left is 2x minus 3 on the top and then negative 3 plus x on the bottom. Or if I wanted, this negative can go on the side of the fraction. That is the same thing, and either way that would be our solution. Now remember that there are restrictions on our fractions. So the denominator, remember, can never equal 0. And to determine what those limitations are, I'm going to look at my original fraction up here. So looking at the original fraction, we know that this bottom cannot equal 0. And if either part of these, 2 minus x or 3 plus x, is equal to 0, then we know the bottom would be 0, right? Because if the first part is 0, we'd have 0 times something, which would be 0, which we cannot have. So 2 minus x cannot equal 0, and 3 plus x cannot equal 0. So we can solve this for x to determine what our limitations are. So for the first one, we can bring the x to the right side by making it, by adding x to both sides, and that will make it positive. So we have 2 on the left side and x on the right side. So x cannot equal 2. And then the other inequality, I can subtract 3 from both sides. So x will not equal negative 3. So those are my limitations. X cannot equal 2 or negative 3. And if it were, if you plug a 2 back in for x, we'd have 2 minus 2, which is 0, which 0 times over here would be a 5. 0 times 5 is 0, which we cannot have. One more example, we have a squared minus a times x equals b squared minus b times x. So for this one, at the beginning, it's not a fraction like the other examples. But by the end of this, it will be a fraction, and we'll explain why. So we want to solve this for x. That is our goal. So x equals something. All right, so to solve for x, we want x on the same side. So to get x on the same side, I can bring the b squared over this direction. So I can do that by subtracting b squared. And then I can bring this negative ax over this direction by adding ax. So if I do that, I'm going to get a squared and then minus b squared on the left side. And then when I move the ax over here, I now have a positive ax and then minus the bx. So I've rearranged this so that x is now on the same side. Now what I like to do is, looking at this right side, I'd like to factor an x out. So I can factor an x out, and I'm left with a minus b in parentheses. All right, so I have x times a minus b. Now from here, x is being multiplied by a minus b. So to get rid of the a minus b, I can do the opposite, which would be divide. So I divide both sides by a minus b. When I divide, the a minus b's cancel. I have x equaling a squared minus b squared over a minus b. So this is where my fraction comes in. And from here, I need to solve. So let me rewrite this up at the top. X equals then a squared minus b squared over a minus b. So what I can do to solve this for x is I can simplify this right side. So I have actually solved for x, but I need to simplify. So a squared minus b squared, that is a difference of squares that can factor to be a minus b, and then a plus b. And on the bottom we have an a minus b. So a minus b is one quantity, that's on the bottom. I can divide a minus b on the top with a minus b on the bottom. So what I have is x equals then a plus b. So my solution is x equals a plus b. And now just remember that there are limitations on the denominator. So looking here at this fraction, we know that a minus b cannot equal 0. All right, that bottom cannot equal 0. So a minus b cannot equal 0. And in relation to a, if we add b to both sides, we have a not equaling positive b. So my limitations is a not equal to b. So as long as a and b are not the same number, then we are okay. And that concludes our lesson for today. We will see you next time.